This is going to be just a short video describing what half-life is. So in an earlier video, I mentioned that the more unstable an isotope is, the faster that they go through radioactive decay. And this is true, but if I have just one atom of isotope, it's impossible to say exactly when it's going to go through radioactive decay. I can't say exactly when my unstable atom is going to decay into another element. But if I had a large amount of that type of isotope, and when we're dealing with atoms, we're usually dealing with a large amount because atoms are so small, I can use an average of how long it takes that to decay. So I could use an average of how long half of them decay. And because I have so many, it'll be a more accurate way of measuring how quickly my atoms go through radioactive decay. So that's what half-life is. Half-life is the amount of time it takes for half of a certain type of unstable isotope to go through radioactive decay. And we have a lot of different isotopes that each have a very unique half-life. So if we take a look at some different isotopes and their different half-lives, we could see that the isotope helium-5 has a half-life of 7.6 times 10 to the negative 22 seconds, which is a very, very short half-life. Whereas bismuth-209 has a half-life of 2 times 10 to the 19 years, which is the isotope with the longest half-life. And isotopes can have half-lives ranging from, anywhere in between that, from seconds to minutes, hours, days, tens of years, hundreds, thousands, millions, billions, so any range in between there. So if we take a look at a common one we're going to see in this class, the isotope carbon-14, that has a half-life of 5,700 years about. And all living things have carbon-14, and after something dies, that carbon-14 starts decreasing because it starts decaying. So if something that used to be living and is now dead has carbon-14 over 5,700 years, half of it will have decayed into nitrogen-14. So after 5,700 years, half of my carbon-14 will have gone away. And then if I wait another 5,700 years, I don't get rid of all of it, I just get rid of another half. So if I have 8 left, half of it would go away. I would only have 4. And then if I waited another 5,700 years, so at this point it's 17,100 years, another half would decay. And if I waited another 5,700 years, another half would decay. So carbon dating is what we call this when we use carbon-14 to the amount of carbon-14 in a thing that used to be living and is now dead. And we can accurately tell how long ago that thing died by seeing how much carbon-14 is left in it. And you can see carbon-14 decays, and over time there's less and less of it. So after about 50,000 years, it starts being less accurate because so much of that carbon-14 has decayed away. So anything that recently died all the way to about died 50,000 years ago, we can use carbon dating and see how much carbon-14 is left in it to accurately see how long ago that thing died.